Okay, this is lesson 75, changing improper fractions to whole or mixed numbers. So a fraction that's less than 1 is called a proper fraction, and a fraction that's greater than 1 is an improper fraction. You don't hear proper fractions too often, but you hear improper fractions a lot. So that means you only have a part of something, so that's a proper fraction. That means you have more than one of something, so it's an improper fraction. So let's look at 5/4 for a minute. Remember 4, the denominator, tells me how many groups to break that whole thing into. So I'm going to break my one whole into 4 groups. But then I have one more, so I have to have another whole, but I only take one of them. So 1, 2, 3, 4, 5 groups of 4, right? So 5/4. The other way I can think about this is there's one whole plus 1/4. 4/4 plus 1/4. So I can either write that 1 and 1/4 or 5/4. Mixed number, improper fraction. Sometimes you use one, sometimes you use another, and you have to ask. In 5th grade, generally speaking, when they tell you to simplify something, they're asking you to turn that improper fraction into a mixed number. When you get a little bit older, in science in 7th and 8th grade, and in math in 7th and 8th grade, you'll probably use those improper fractions as they're written more often. The other thing I want to tell you that's not in the book, that I think we've talked about this, that a fraction is a division problem. So 5 divided by 4, right? Remember we said the top number always goes in the box? So I'm going to put the 5 here as my dividend. My 4 is my divisor. I say 4 goes into 5 one time, multiply, subtract, check, nothing to bring down, so I have a remainder. So remember turning your remainders into a fraction. Your remainder is your numerator. Your divisor is your denominator. So any fraction can be a division problem, okay? It's an easy way to change improper fractions into mixed numbers. All right. Let's look at example 1. Hold on, let me get organized here. Okay, that says separate 8/3 into fractions equal to 1 plus a proper fraction. Remember, a proper fraction is less than 1. So I'm not so good at the circles. Talked about that a lot. So I draw bars. So I have one whole broken into 3 parts, another whole broken into 3 parts, and another whole, but I only have 2 of them. So I broke it into 3 parts and took 2. So I have 1, 2, 3, 4, 5, 6, 7, 8. So 8/3 tells me that I have 2 whole things, there's my whole number, plus 2/3 of another thing, and there's my proper fraction. Does that make sense? I can do the division, the same thing. I can make that a division problem. The 8 goes in the box. Top number always goes in the box. So 3 goes into 8. 2 times minus 6, I get 2. So there's my remainder becomes my numerator. My divisor becomes my denominator. So 8/3 is the same thing as 2 2/3, and I can do it either way. Example 2 says the chef baked 2 lemon pies. At the end of the day, 3/5 of one pie and 4/5 of the other pie remained. Who cuts pies into fifths? Nobody. Whatever. Altogether, how many lemon pies remained? Okay, so I know that I want to add 3/5 and 4/5, right? Because I have 3/5 of one pie and 4/5 of another pie. I add them together, I get 7/5. Well, if I kind of break them apart again, I can say, oh, 5/5 plus 2/5 is the same thing, isn't it? So I could just take one of those pieces and put it over here, and then I'd have a whole pie with some cuts in it. So 7/5 is 5/5 plus 2/5. So that 5/5 is the same thing as 1. So 7/5 is 1 plus 2/5, or 1 2/5. Here, if I wanted to do that one, I would have 3/3 plus 3/3 plus 2/3. 3 plus 3 is 6, 7, 8. So there's 1, 2, and 2/3. So I can always do that. I can take my 1/2s out of there. Okay. Example 3 says a 3-person crew worked for 2.5 hours to repair a broken water line. The customer will be billed for how many hours of work? So they get billed from each person, right? So I have to add all the people's work together. So person 1 worked 2.5 hours. So there's my 1 hour, 2 hours, and a half hour. Person 2, 1 hour, 2 hours, and a half hour. Same thing, okay? So how many half hours do I have? I have 15 half hours. So I can do my division here, or I can just say 2.5, 2.5, 2.5. So I'd have 6 wholes plus 3 halves. I can think about it that way. I can do my division. 2 goes into 15 7 times, and I get 7.5. Or I can add them this way. Remember when I'm adding mixed numbers, I like to do it vertically, and I divide the columns between my fractions and my whole numbers. So 1/2 plus 1/2 plus 1/2 is 3 halves. Remember, when you're adding fractions, you don't add the denominator, just the numerators. And then 2 plus 2 plus 2 is 6. So I have 6 and 3 halves. Well, that's the same thing as 6 plus 2 halves plus 1/2, right? And that's 1. So 6 plus 1 is 7 plus a half. And I get 7.5. It's a lot of steps that you probably won't have to take, but I wanted to explain the reason why you can do all of those things. In my mind, this is the easiest way to do this if you want to do it fast. But if you want to understand the reasoning, drawing it out is really helpful. All right, good luck with this stuff.